Okay, here we are. We're going to start our review for the test. So here we have some information, and the first question says calculate the probability that a student prefers a tablet. So the first thing I'm going to do is I look. Okay, there's 560 tablet owning people out of our total, which is 1280. Okay. Question B says, what's the probability that the person is 11 through 13 years old and prefers a mobile phone? So 11 to 13 years old and prefers a mobile phone has to satisfy these two requirements. Okay, out of our total. Now our next one is a conditional probability. Given that they are 17 to 18 years old, means my denominator has to be 348. Okay, because these are all the 17 to 18 years old, and they have to be given that you're 17 to 18 years old. So you're only choosing from here, and the probability that you have a laptop is 153 out of this value here. And then the next one, the probability that you prefer a tablet or you're 14 through 16 years old. So anybody 14 through 16 years old is these. Oops. I meant to. Okay, this is that category, right? Anybody 14 to 16 years old is these people, and anybody that prefers a tablet is these people. So if I add all three of these and these two, then we get 848. A lot of people were missing this one here. They were, in the numerator, they were writing 560 plus 512, which is not correct. It's not 560 plus 512. That is not correct over 1280. So and the reason it's not 560 over 512 is because that would count the 224 twice. Okay, so calculate chi-squared test for independence. So our null hypothesis is that a person's device preference is independent of their age. Their alternative hypothesis is the person's device preference is not independent of age. Okay, so my degrees of freedom, you take the rows minus 1 times the column minus 1. So, and then we end up with degrees of freedom of 4. Now let's calculate the chi-squared and p-value with our calculator. So you should be using this packet here to follow the calculator instructions. But let me do this with you guys together. Okay, so I need to press second x to the -1 button in order to get to my matrix things. I need to go over to edit, and then I hit enter. And now we have a 3 by 3 matrix, so I'm going to type in 3 there. And so now I've got my 3 by 3 matrix, and I'm going to type in these numbers: 143, enter, 160, enter, 153, 205, 224, 131, 72, 28, and 64. Okay, hopefully I typed in all these correctly. Okay, so now I've entered my matrix. Second mode to quit. I go to stat, over to test, and then I'm going to arrow down, 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 down until I get to chi-squared. Okay, GOF is goodness of fit. We'll be doing that a little later on. So there's my chi-squared test. I hit enter. I've typed it into A. Hit enter. And now I get my chi-squared value is 23.3, and I get a p-value of this. Now, I'm warning you, if you type in if you write in 1.08 e to the negative 4, I'm not going to give you any credit. Okay, so so here are those answers. 1.0899 e to the negative 4 means 1.0899 times 10 to the negative 4. The calculator doesn't write 10 to the negative 4 for whatever reason. So I will accept either of these answers, but I will not accept this answer. Okay, so then we compare it to our compare it to something. We compare it to our table from 8C, which and our table from 8C helps us determine whether or not to accept the null hypothesis. Okay, so if my calculated value is less than the critical value, we accept. If the calculated value is greater than the critical value, we reject. And so let's look at what did we get. We had 23.3, and the critical value they gave me is 13. So my calculated value is bigger than the critical value. So with the calculated value bigger than the critical value, I'm rejecting the null hypothesis. And that's what I wrote here. I reject null hypothesis because this is bigger than this. Also, I could look at this p-value and notice this p-value is smaller than, let's see, we're doing this at 1% significance. So 0.01 is 1%. And this p-value is smaller than that. So whenever you have the p-value smaller than your percent significance, once again, we reject the null hypothesis. So it doesn't matter if you write this reason or this reason. They both indicate the same thing. They both indicate that we reject the null hypothesis. So personal device preference is not independent of age. If we accepted the null hypothesis, it would be personal preference device is independent of age. Okay, you might want to hit pause if you need to. Okay, next. Okay, so we've got two types of rabbits, a chinchilla rabbit and a sable rabbit. And the question is, we've got the different rabbits, and they're recorded. And the aim is to find out whether the chinchilla rabbits are heavier than sable rabbits. So if they're heavier, then we know that we are trying to determine, this is going to be a one-tail test, because the one-tail test is when we want to know which one is better or which one's heavier. Okay, so it's going to be a one-tail test because of the word heavier. We want to know which one is heavier. So since the chinchilla, so we want to know if the chinchilla rabbits are heavier than the sable rabbits. We want to know if the first row is larger than the second row. So we're going to use this function on the calculator. Okay, so this part right here is going to be the critical part on the calculator in just a minute. So my null hypothesis is there's no difference between weight of chinchilla and sable rabbits. My alternative hypothesis is that they are that the chinchilla rabbits are generally heavier than sable rabbits. Okay, And this one, there's no difference. Okay, so as I said, it's one tail because we want to know which one is heavier. You might want to hit pause. So if I enter all the data in here, okay, if I enter all the data, then we get, let's see, 4.9, 4.2, 4.1, 4.4, 4.3, 4.6, 4, 4.7, 4.5, 4.4. Okay, 4.2, 4.1, 4.1, 4.2, 4.5, 4.4, 4.5, 3.9, 4.2. Okay, so I've entered my data. I go over to stat, and I'm going to arrow down to, I'm going to go to tests. I'm going to go down to the fourth one, which is sample t-test. So I hit, because we're doing a t-test here. So because I'm comparing the two groups, I've got L1 and I've got L2. And since I want to know if row 1 is bigger than row 2, I need to go over here and change this and hit enter here. So I want to use, now if U1 is bigger than U2, I hit enter, calculate, and then I get my t value, which was 1.84, and my p value, which is 0.408. Okay. So when I'm comparing my t-test, I'm going to have to use the p-value to determine whether or not we reject the test. We're not going to be using the t-value in this course for determining accepting or rejecting. So as it says in the problem, we're going to do it at 5% significance. So that's why I'm using 0.05. And we see that this value is less than the 0.05, and when that p-value we've calculated is less than 0.5, we reject the null hypothesis. Okay. As I mentioned in class, this question, part 3, is not there was a mistake with it, so we're going to talk about this. I have an alternative problem for future students. But we are going to continue to do 3F. So we've got our data here, and 3F says we're going to put this, and we're going to do a Spearman ranked correlation. So in order to do the Spearman rank correlation, we have to order them. So we're going to have this rank as 1, 2. We're going to put them all in order. So 1, 2, 3, 4. And so the heaviest one, the highest rank is 8. And then I look here. So if I'm starting with the 4,215 as 1, then the next highest number is D. I'm going to put 2 there. The next higher number is B. I'm going to put a 3 there. And anyways, this is my ranked correlation. For F, for number of pages, 209 is the smallest value, and I'm going to put 8 there. You might want to hit pause. So then I use the Spearman ranking, and I put that into my calculator. Stat, enter, clear, clear. And then let's put these values in here. 1, 3, 5, 2, 6, 8, 4, 7. Go over here. 1, 2, 3, 4, 6, 7, 8. Okay, so now I've got my 2 rows in here. I go to Stat, arrow over to Calc, go down to Linear Regression when we're trying to find R values, and then I find that my R value is 0.714. So now I have to go back to, we did this in Chapter 6, and I gave you this table here to help us determine what our R value means. If our R value is 1, we have a perfect positive correlation. If R is -1, it's a perfect negative correlation. And then anything in between, as you get closer to 0, it's very weak. So 0.714 falls kind of right here, moderate, and it's a positive number, so moderate and positive. So the important things I want to see on your test would be moderate and positive. Okay, next question. Okay, so the dice manufacturer claims for a novelty die that he produces that the scores 1 through 5 are all equal. The probability of getting a 6 is 2 times more likely than any other die. Find the probability of the score of 6 when rolling the novelty die. So the probability of getting 1, 2, 3, 4, 5, those are all the same. Probability of getting a 6 is twice as likely, so I'm going to say 6 and 6, which would give me a 7 if I had this on a spinner. And we would have 1, 2, 3, 4, 5, 6, and then 6 again, because 6 being twice as likely. That would give us 7 options. Okay, so we have a 2/7 chance of getting a 6 when rolling this funny die. Okay, so now we're going to roll this 350 times. So for these here, the probability is 1/6, and I'm going to multiply 1/6 times 300, and we get a value of 50. And the last one we multiply 1/6, that's not right, 1/7. 1/7 times 350. And then we get 50. And if I have multiplied 2/7 times 350, we're going to end up with 100. You might want to hit pause and think about this for a second. Okay, so the IB solution key says that the null hypothesis is that the manufacturer's claim is correct, and the alternative hypothesis is the manufacturer's claim is not correct. In our textbook problems, we had the answers of the die satisfies normal distribution or uniform distribution, and the die does not satisfy uniform distribution. In this problem, I would have accepted either of these answers. And on the test, I'm going to have them all being the same, not different like this. So this was an unusual problem, and we'll be doing other problems where the values aren't the same in a later chapter. Anyways, in my calculator, if I make this value L1, and if I make these values L2, then I will use that information to help me get my chi-squared and my p-value. So let's do that. Stat, enter. Oops, clear. Clear. All right, so 32, 57, 47, 58, 54, 102. Okay, over here, 50, 50, and then 100. Okay, stat, arrow over to calc, tests. We're doing a goodness of fit test. So when you're doing a goodness of fit test, you have to arrow down all the way to chi-squared goodness of fit test. Enter. L1, L2, degrees of freedom. Okay, so to do degrees of freedom, we're going to see how many columns do we have. 1, 2, 3, 4, 5, 6, right? So my degrees of freedom is the number of columns or number of rows, whatever it is, minus 1. And that since n equals 6, because you can get row of 1 or a 6, 1 through 6, we know that the df is going to be equal to 6 minus 1. So the degrees of freedom is going to be equal to 5, which is what I have here. Okay, so I hit enter, and I get my my chi-squared value of 9.28 and my p-value of 0.984. Okay, and so I've got these values here. And so now I want to make a comparison of this since we're doing this at a 5% significance, I can compare this p-value to 5%, and as we can see, this is greater than 5%. So if I go back to this chart, if it's greater than 5%, we accept the null hypothesis, and so the manufacturer's claim is correct, or it satisfies the uniform or the distribution. Okay. Next question. Okay, so you plot the points. Then you take the average of the x values, average of the y values. You should get this. If you type in these values and the x and the y, you should get a value that's really, really, really close to -1. And okay, let's type this in so that you guys can see how this works. Okay. So we've got 8. Oops. Clear. Okay, 8, 15, 22, 30, 34, 45, 50, 60, 74, 82. Okay. 80, 77, 74, 69, 68, 61. Alright, we've typed them all in. Stat. Okay, so now we're doing linear regression, so I go over to calc, down to 4 for linear regression. Oh, we don't need that 8 there. Let's clear that. Okay, let's do that again. Stat, here over to calc, down to linear regression. And I have my A value, my B value, and my R value. So A and the B are going to tell you the value for my slope and my y-intercept. So here is my slope, which is the A value, and here's my y-intercept, which is the B value from the calculator, as you can see. And since my R value is -1, when I go to this chart here, -1 means I have a perfect negative correlation. So I'm going to look for the words perfect, and I'm going to look for the words negative. Okay, and then question G says estimate the output when we have a 25% moisture content. So essentially, you're just plugging in 25 into the x value, and we get 71.9 heat output. Okay, so extrapolation is when a prediction is outside the range. Okay, what does that mean? So at the beginning of this unit, we did, if I can get it out here, at the beginning of this unit, when we did chapters outliers and that's in extrapolation. Extrapolation, we learned, was when you have data, when you're trying to make a prediction outside of your data. So if all of my dots are within a particular range, then, and I make a prediction somewhere in between where the dots are, that's called interpolation. My data is in between where the data is. If I'm trying to make a prediction that's outside of where my data is, that's called extrapolation. So basically when I'm making a prediction that's outside of my data range. So is plugging in 25 in here correct or useful? And we can, because if I plug in 25, my value is somewhere around here. Okay, so because it's between the data range. Okay. Last question. Okay, so the range between weights, basically I take the heaviest animal and the lightest animal and I subtract their weights. Okay. You put this in here, you get your R value. An R value of 0.92, when you look at your table, 0.92 is strong and positive. And if you wrote very, that's fine. Okay. And when you plug it into your calculator, you're going to get an A and B value like this. And then an average body weight of a wolf is 36 kilograms. So what do you expect the weight of their brain to be? I plug in 36 in place of X, and then I get this value here. And then finally, percentage error. We haven't talked about that in so long. Oh my gosh, what is percentage error? Okay, so fortunately, I've got my handy dandy formula packet, and let's see what percentage error. What is percentage error? Oh, here it is. Percentage error is the approximate value minus my exact value divided by the exact value, and then you multiply it by 100 to convert it to percentage. So approximate value minus the exact value divided by the exact value. So here is my approximate value from here. Okay, this is the actual value, not this from the calculator. And then they've told you the actual value, which goes right here and here, and then we get 6.52%. I hope this helps.